Download this code from codegive.com, link in the description below. OK, let's dive deep into converting decimal numbers to binary numbers using C programming. This tutorial will cover the concepts, the logic, different approaches, and provide a well-commented code example. Understanding decimal and binary number systems. Before we write any code, let's refresh our understanding of decimal and binary number systems. Asterisk decimal, base 10. This is the number system we use every day. It has 10 digits, 0 to 9. Each position in a decimal number represents a power of 10, example in 123, the 1 is in the hundreds place, 10 squared, the 2 is in the tens place, 10 to the power of first, and the 3 is in the ones place, 10 to the power of 0. Asterisk binary, base 2. This number system has only 2 digits, 0 and 1. Each position in a binary number represents a power of 2, example in 101, the 1 on the left is in the 4's place, 2 squared, the 0 is in the 2's place, 2 to the power of first, and the 1 on the right is in the 1's place, 2 to the power of 0. The conversion process, decimal to binary. The most common method to convert a decimal number to its binary equivalent is the repeated division by 2 method. Here's the breakdown. 1 divide by 2 asterisk divide the decimal number by 2. To note the remainder asterisk keep track of the remainder, which will be either 0 or 1. 3 repeat asterisk use the quotient, the result of the division, as the new decimal number and repeat steps 1 and 2. 4 continue until the quotient is 0 asterisk keep dividing until the quotient is 0. 5 read remainders in reverse order asterisk the binary number is formed by reading the remainders in reverse order, from the last remainder to the first. Example asterisk. Let's convert the decimal number 13 to binary. Division quotient remainder. Dash dash dash. 13/261. 6/230, 3/211, 1/201. Reading the remainders in reverse order, 1101, we find that the binary representation of 13 is 1101. C code implementation, integer decimal to binary. Here's a C program that implements the decimal to binary conversion for integer numbers. Explanation of the code asterisk. Asterisk includes stdio.h asterisk includes the standard input/output library for functions like printf and scanf. Asterisk includes stlib.h asterisk includes the standard library, which provides functions for memory allocation, malloc, free, and other utility functions. Asterisk include math.h asterisk includes the math library to access math functions like log and ceil, needed to calculate number of bits. Asterisk decimaltobinary underscore array, int decimal number, asterisk this function converts the decimal number to binary using an array to store the individual bits. Asterisk it first initializes an integer array binary of size 32, assuming a 32-bit integer representation. Asterisk the while loop performs the repeated division by 2. Asterisk the remainder of each division is stored in the binary array. Asterisk finally, the binary array is printed in reverse order to get the correct binary representation. Asterisk decimaltobinary underscore integer, int decimal number, asterisk this function attempts to store the entire binary number as a long integer. Asterisk limitations asterisk this method has a limitation, it can only handle decimal numbers that result in binary representations that fit within the range of a long integer. It's good for relatively small decimal numbers. Asterisk it uses the same repeated division logic. Asterisk it constructs the binary number by multiplying each remainder by a power of 10, to place it in the correct digit of the binary number, and adding it to the binary number. Asterisk decimaltobinary underscore bitwise, Int decimal number, asterisk. This function is generally the most efficient method because it uses bitwise operators. Asterisk. It iterates through each bit position in a 32-bit integer, from the most significant bit to the least significant bit. Asterisk k equals decimal number I, this right shifts the decimal number I bits. Right shifting moves the bits to the right, effectively dividing by powers of 2. The rightmost bit after the shift is the bit we're interested in. Asterisk. If k and 1, this performs a bitwise AND operation between k and 1. If the rightmost bit of k is 1, the result will be 1, otherwise, it will be 0. This tells us whether the bit at position I in the original decimal number was a 1 or a 0. Asterisk. The function then prints 1 or 0 accordingly. Asterisk. Decimalto-binary underscore dynamic, int decimal number, asterisk. This function demonstrates dynamic memory allocation. It allocates memory on the heap to store the binary string. Asterisk. Int number bits equals, int, ceil, log, decimal number plus 1, / log, 2, this line calculates how many bits are needed. The log base 2 of decimal number plus 1 tells us the approximate number of bits. Ceil is used to round up to the nearest integer to ensure enough memory is allocated. Asterisk. Char asterisk binary equals, char asterisk, malloc, number bits plus 1, this allocates memory dynamically to store the binary string. Malloc allocates the specified number of bytes. We allocate number bits plus 1 bytes because we need space for the binary digits plus a null terminator, \0, to mark the end of the string. Asterisk. The remainders are converted to character representations, 0 or 1, and stored in the binary string. Asterisk. Since the remainders are calculated in reverse order, the string is reversed using a loop. Asterisk. Important asterisk. The main function then calls free, binary string, to release the memory that was allocated by malloc. If you don't free the memory, you'll have a memory leak. Asterisk. Main, function asterisk. Asterisk prompts the user to enter a decimal number using printf. Asterisk reads the user's input using scanf. Asterisk calls each of the conversion functions and prints the results. Asterisk. The main function also demonstrates the proper use of malloc and free when using dynamic memory allocation. How to compile and run the code asterisk. 1. Save the code asterisk. Save the code as a .c file, example decimal underscore to underscore binary.c. 2. Compile asterisk. Open a terminal or command prompt and use a C compiler, like GCC, to compile the code. Asterisk. GCC, the GNU C compiler. Asterisk. Decimal underscore to underscore binary.c, the name of your C source file. Asterisk. O decimal underscore to underscore binary, specifies the name of the executable file, example decimal underscore to underscore binary. Asterisk. LM, links the math library, required because we use math.h functions. 3. Run asterisk. Execute the compiled program. The program will prompt you to enter a decimal number. Enter a number and press enter, and it will display the binary equivalent calculated using the different methods. Important considerations asterisk. Asterisk. Error handling asterisk. The code could be improved by adding error handling. For example, you could check if scanf successfully read an integer and handle cases where the user enters invalid input. Asterisk. Negative numbers asterisk. This code is designed for non-negative integers. To handle negative numbers, you'll need to consider how negative numbers are represented in binary, example using 2's complement. The bitwise method is usually the most direct way to convert negative numbers to binary using 2's complement representation. Asterisk. Floating point numbers asterisk. Converting floating point numbers, example 3.14, to binary is more complex and involves representing the number in terms of a sign, exponent, and mantissa, similar to scientific notation. This is often covered in the IEEE 754 floating point standard. It's beyond the scope of this basic integer to binary conversion tutorial. Asterisk memory allocation asterisk when using dynamic memory allocation, with malloc, it's crucial to free the allocated memory when you're done with it to prevent memory leaks. Asterisk bitwise operator efficiency asterisk the bitwise operator method is generally the most efficient because it directly manipulates the bits of the integer, without the overhead of division and multiplication. Code improvements and extensions asterisk. Here are some possible extensions to the code. 1. Handle negative numbers, 2's complement. In this example, casting the decimal number to an unsigned int ensures that the bitwise operations treat the number as a sequence of bits, regardless of whether it's positive or negative. This is important for correctly handling the 2's complement representation of negative numbers. Note that the output is then the 32-bit 2's complement representation of the number. 2. Error handling asterisk. This example checks the return value of scanf. If scanf doesn't successfully read an integer, example the user enters text, it returns a value other than 1. The code then prints an error message to str, standard error, and exits with a non-zero return code, indicating an error. 3. Variable bit length asterisk allow the user to specify how many bits should be used to represent the number. This version takes the number of bits as input from the user and uses that value in the loop to print the binary representation. It is important to be aware of potential issues like overflow when you provide a small number bits value for larger numbers. This comprehensive tutorial should give you a solid understanding of how to convert decimal numbers to binary numbers in C, along with code examples and important considerations for improving and extending your programs. Remember to compile and run the code to experiment and solidify your knowledge.